Hi everyone, I wanted to put together a quick video for page 10 just in case you needed a little bit of extra support or you wanted to hear it a different way. I wanted to start just by making a connection to what's happening with vertex form and why it's even a thing. Hopefully this will be just a quick kind of flashback to something that's familiar that'll help. I'm going to start with y equals mx plus b. Remember, this is the most common format for the linear equation that we worked with pretty much most of quarters 1 and 2. Even though that was a really common setup for the equation, so slope-intercept form, we also saw the linear equation written in standard form, where it looked a little bit different, and depending on what we were doing with it, maybe even standard form was a better way to have it. It didn't really matter though, because remember, these two equations were equivalent. They were just set up in different ways. That's what's happening now with vertex form. So we have our quadratic equation, which is y equals ax squared plus bx plus c. Vertex form is just a different way to see the quadratic equation. It's set up with some similar components, but in general it just looks different and has some different letters kind of thrown into the mix. So for your vertex form of a quadratic equation, it's y equals a multiplied by x minus h all squared plus k. So what's really nice about vertex form is that you can find things like your axis of symmetry and your vertex without having to do as much work as you were doing when we had standard form on the first pages of this unit. So I'm going to clear out the space over here to the right and then kind of show you what's going on with these. So let's start with just kind of filling in what the letters represent first. HK is your vertex. So if you're able to pull the h value and the k value from your vertex form equation, that's all you need for your vertex. And we don't have to set it up the same way that we were doing with all of those examples on previous pages. X equals h is your axis of symmetry. All that really means is that whatever your h value is, that's going to represent your axis of symmetry, and we don't have to worry about using the -1 times b over 2 times a formula. So it's just an alternative way to get there. So when you start looking at these pieces, when I go back to the blue here, your h value does have that minus sign sitting in front of it, which really just means that for all of these, when you pull out your axis of symmetry, you're going to do the opposite of that value. For example, on number 1, the number that's sitting in the position for h is a 4. So that means our axis of symmetry would be a -4. Or for number 2, the number that's sitting in place of h is a -3. The opposite of that would mean that our axis of symmetry is a +3. Number 3, the number sitting in the h value, h spot is -5. The opposite of that would be +5. Okay, number 4. This one is a little bit different because it's not set up with the parentheses and all these other things. But honestly, with this one, why not use the formula that you already know? -1 multiplied by b over 2 times a. There is no b value, so it's -1 times 0. The a value is -2. And when we solve this, we just get that our axis of symmetry is a 0. So with these, it's okay to kind of flash back to things that you already know how to do, right? This formula with the -1 times b over 2a, that doesn't go away just because it's a different format. We're just kind of building on what's available for you so that you have options when you start looking at these. Okay, so just because it's a different page and a different form of the equation doesn't mean that this stuff goes away. Right, so we have axis of symmetry for the first 4 now. Okay. The next part is looking for the vertex. Well, for vertex, we know that we need to use that x value from the axis of symmetry. So for number 1, our x value is -4. And number 2, our x value would be 3, and so on. So I'm just filling in our x values. And here you have a couple options, okay? Just like with those first pages that we did, you can plug in those x values to the equation and solve for y, right? But what it's saying up at the top with this HK business is that you could pull that y value by just looking at what's sitting in the k position of your equation. So for number 1, that k position is a -2. That's your y value on the vertex. For number 2, there is nothing sitting in this k position, so we would put a 0. For number 3, -4 is sitting in the k position. That's going to go here for our y value. And for number 4, with this one, we do have something sitting in the k position. But again, if you wanted to kind of go back to the way that we were doing this before, all we'd have to do is plug in a 0 for x and see what happens. We end up getting 3 for this answer. All right, and really with these, again, the idea of the shortcut here is that we're using these letters h and k from this vertex form of the equation to help us find these answers without having to do it the way that we were before. But definitely you could still solve these the same way that we had when we were going through this on the first pages. So just as an example to kind of show you what I'm talking about, let's look at number 3. So for number 3, we knew that x was 5. If you go back to the original equation and plug in a 5 for x, and then solve this, you end up getting -4 for your answer. And -4 is what we had from that k value on the end. Right, so whatever you end up choosing here, it's going to work out. I'm going to show you another thing while we're still working with these same examples. With, let's do number 1. With number 1, the vertex form right now is x plus 4 squared minus 2. If you don't like seeing it this way, or if you're just not confident in what's happening and you want a chance to kind of check it out and see, the similarities, we could simplify this. You could go ahead and solve it as if we were using order of operations. So we could do this part first with the exponent. Remember, to multiply this together, you could use the Bots method, you could use FOIL, right? So this is where those polynomial pages come back in. If I use the Bots method here, I get x squared, a 4x, a 4x, and a 16. And then we also have that -2 still hanging on the end. When I simplify this all the way, I get x squared plus 8x plus 14. This would be standard form of the quadratic equation. So this is literally what the first couple of pages look like. From here, if we wanted to do axis of symmetry, the formula is x equals -1 times b over 2 multiplied by a. That would be -1 times 8 over 2 times 1. We get that x equals -4. If you go back over on the left to number 1, that axis of symmetry number is -4, right? So it works out either way. You have some options with this. All right, let's look down at the bottom. So for number 5, again, keeping in mind that you have some options, very first thing with this would be to recognize what values would be your h and your k. So if we're doing this using shortcuts so that we can have a little experience with the h and k values here, for axis of symmetry, we're looking at the opposite of our h value. So x would be -2. It's the opposite of the h value. For vertex, we know that our vertex is represented by our h value. So our h value is going to be that -2. And we know that the y is represented by the k value, and the k is 7. And we've got our h and our k values, and that's all we needed for axis of symmetry and vertex. Alternatively, we could take this equation and simplify it. So if I do the multiplication with the exponent first, that means that I'm looking at x plus 2 times x plus 2. So you could do the bots method, you could do FOIL, whatever setup you want to go with. I'm going to do the bots. I end up getting x squared plus 4x plus 4. The next step using order of operations would be to distribute that -1. And then the last step would be to combine these like terms together that are on the end. And all this stuff in red is just turning it back into standard form, like how we saw it previously. That way you could kind of check out how similar the process is and where these answers are coming from. This would be the standard form of that equation. If we were doing axis of symmetry from here, it would be -1 times b over 2 times a, which ends up equaling -2. Again, we already knew that from before, but here's another way to see it. And then if you wanted to solve for the y value of your vertex, we could plug that -2 in and hopefully get the same answers. Let's check that out. This would be -2 squared. That's +4 times -1 is -4. -4 times -2 would be +8. And then from left to right, -4 plus 8 plus 3 is 7. And these are the same two numbers that we ended up using up here at the top in blue. Right. So just keep in mind, vertex form is a different way to look at the quadratic equation. Technically, you could solve it all out and put it in standard form if you wanted to. I think that's a lot of extra work. At this point, the idea is taking that shortcut and knowing that the axis of symmetry is represented by doing the opposite of your h value, and the vertex is your h value and k value put together. So number 5, we've got some answers here. We've got -2 for axis of symmetry, -2, for vertex. With number 6, for axis of symmetry, if I do the opposite of the h value, I would get +1. For the vertex, the k value is 0. As far as filling in the table, graphing this, domain and range, all of this is going to be just like what was happening before. So on the calculator, you can go to y equals, type in the equation exactly like you see it, including the parentheses, and then go to second graph. That way you can input the points that you're looking for. For your table, the axis of symmetry will go in the center, and then you can build from there. Again, doing it this way helps to ensure that the numbers that you put are going to fit on the coordinate plane that's available. So for number 5, these would be the x values that we're trying. If you want to go ahead and enter this into the calculator, pause the video for just a sec, and then come back and make sure that you have the right numbers. All right, from here, domain and range, again, just like from previous pages, domain is always going to be all real numbers for quadratic equations. That U-shape's going to keep going infinitely, either up or down, depending on how the graph is turned. So all real numbers. For the range, remember it's y, a symbol. Since this is a parabola going down, we're using less than or equal to. And then the maximum y value that we have is a 7. So y is everything less than or equal to 7. For number 6, that axis of symmetry is going to go in the center of our table. We're going to get our other numbers here. Again, pause if you're trying to enter this in yourself to make sure that you're getting the right numbers. I'm going to go ahead and fill in the y values. Remember, from this, without even seeing the graph, we know that domain will be all real numbers. I'm going to go ahead and graph this so we can see our U-shape. When I graphed this, I went by 2s just so the 12s would fit on the coordinate plane. So you could set this up however you wanted, but in order to get it to fit, I did go by 2s. Yeah, so there we go. For the range, again, it's always going to be y, a symbol. For this one, the symbol is greater than or equal to, and our minimum y value is 0. All right, so I know this video was a little long. I hope it helped. If there was anything with vertex form that you needed some clarification on. For the transformations, remember a lot of this is going to be set up the exact same way. Looking at page 11, just from here, I can tell that it's going to look a little different just because it jumps right to a table and doesn't necessarily give you anything else to go off of. But I do want to show you just maybe the setup for the first one so you can kind of see what's happening. Again, I don't have that page on the screen, but I think we can still get pretty far here. So for number 7, all it gives you is the vertex form of the equation, right? And then it gives you a table. And it doesn't really list table of values. It doesn't have all the blanks asking for axis of symmetry and vertex and that whole breakdown. It's just something you kind of have to do yourself, right? So for this one, I'm going to go ahead and identify my axis of symmetry. For this, remember it's going to be the opposite of the h value, so -2. For the vertex on this one, I know that I'm looking at -2 for the x, and then the k value is a 0. On your table, that vertex is going to be what goes in the center. So I'm going to put -2, 0 right in the middle, and then you would build from there. So we would go back to -3, -4, forward to -1 and 0. All right, once you have this, you can enter all of this into the calculator. I get 41014 for my values. And then with this one, we're just graphing. Already on your graph, you're going to notice an equation from above. So the U shape that you already see is from y equals x squared. So what we're really doing is kind of graphing this new parabola around that. So for this, if I plot these points, let's see, -3, 1. All right, so it's the same size U shape. It's just kind of shifted. In fact, you can see exactly how it's been shifted. It goes 2 places to the left. So over there where it says transformation, what it's asking is basically what ended up happening to your U shape. Our parabola went 2 places to the left, and then that's it, 2 left. All right, remember you can still email or send remind messages. I can try to do examples for any of the ones that you need to see. Over the next couple days, though, it might be a little harder to get in touch, but I'll be back and checking out things next week.